For a short period of time, the motor turns gear A with a constant angular acceleration of 4.5 radians per second squared, starting from rest. Determine the velocity of the cylinder and the distance it travels in 3 seconds. So, the cord is wrapped around pulley B, or D, and rigidly attached to B. So this pulley is being turned, which in turn turns this pulley this way, which in turn wraps the cord. Okay, so first we want to find eventually the acceleration of C, and then with that acceleration we can find how far it travels and its velocity. So the velocity at P is the same on pulley A as it is for pulley B. So if we say AP is equal to alpha R, that alpha being A here, so I'm going to call that A at point P. So AP is equal to 4.5 radians per second squared times 75 millimeters, which will give us an AP of 337.5 millimeters per second squared. And since the AP here is equal to AP there, we can now find the acceleration, angular acceleration of that by saying that alpha of B is equal to AP over R. So that is 337.5 divided by the new radius of 225, which gives us an alpha of 1.5 radians per second squared. Now, the inner pulley D is rigidly attached to B, so they rotate at the same alpha. So the velocity at P prime, or the acceleration at P prime, AP prime, is equal to alpha B times R. This time it is 125 millimeters because it's the radius of D. So AP prime is equal to 1.5 times 125, which is equal to 187.5 millimeters per second squared. So now that we're in linear motion, we can say that V is equal to AT, because again, this is a constant angular acceleration. Okay, so V is equal to 187.5 times the time of 3 seconds, right there. So that turns at a rate of 562.5 millimeters per second. And the distance it travels, we'll use the distance equation, S equals S naught plus V naught T plus 1/2 AT squared. This is 0 and this is 0, so S equals 1/2 A of 187.5 T, which is 3 squared, gives a distance traveled of 844 millimeters.